So for our first one, the problem says, for the function f, construct and simplify the difference quotient. So the difference quotient is f of x plus h minus f of x over h. Now, I like to do this in different colors. I don't know if students like that or not, but I'm going to do it in different colors. So the first thing that you do is you find f of x plus h. So that means that I've got to plug x plus h in for this x and for that x. So I have 3 times x plus h squared plus 8 times x plus h. Okay, so that's my first step. My second step is I subtract my original f of x. That's what I do next. So I am going to subtract 3x squared plus 8x. And what students forget to do is they forget to distribute that negative. That's where students make mistakes there. Then my third step is I divide everything by h. Okay? And then my last step is I simplify. Now I'm going to go back to some of the colors as I'm simplifying, just so you can see which part I'm simplifying. So the first thing, I'm going back to the blue. So I'm going back to f of x plus h. I am going to do x plus h squared down here. X plus h squared, what that means is x plus h times x plus h. What students do is they end up doing x squared plus h squared, and that's not correct. You've got to FOIL this. This is x squared plus xh plus xh plus h squared. And that's first, outer, inner, and last. So that simplifies to x squared plus 2xh plus h squared. Okay? So this right here is going to replace this right here. So what do I still have to distribute there? 3. Okay. Okay. So I've only dealt with this x plus h. Now I'm going to add 8 times this. So I'm going to do 8x plus 8h. So I have distributed my 8. I still have some more simplifying that I've got to do with the trinomial, but I went ahead and distributed that. Now I am subtracting my original f of x. So I have minus 3x squared minus 8x. Okay? So I then subtracted. So now I'm going to keep my divided by h. Okay? I'm going to distribute my 3. So I have 3x squared plus 6xh plus 3h squared. Okay. I'm just rewriting the rest. I went ahead and distributed. Okay. Now that I have all of that multiplied out, now I'm going to simplify. 3x squared and minus 3x squared cancel. 8x and minus 8x cancel. So I am left with 6xh plus 3h squared plus 8h. Okay, my final step, I've got an h in every one of these, so I can factor that out. So I'm going to have h times 6x plus 3h plus 8 all over h. My h's cancel, so my final answer here is 6x plus 3h plus 8. And that is my final answer. Okay. Difference quotient typically is one that students struggle with. They kind of forget how to do it. So definitely make sure you've got that. You've kind of got that thought process there.
How many questions are on the test?
12 to 13.
12 to 13.
Okay. Number 2 is G composed of F, and it is of 25. Okay. F of X is X minus 1 over 4, and G of X is 8X plus 7. Now this one is G composed of F. G composed of F. So that means G of F of 25. So I am going to plug the 25 into F of X first. So I'm going to say 25 minus 1 divided by 4. 25 minus 1 is 24, divided by 4 is 6. So F of 25 is 6. So now I'm going to find G of 6. So I take this right here and I plug it in. Okay? So then I've got 8 times 6 plus 7. So 48 plus 7 is 55. And so that is my answer right there. Okay? Okay, and this is number 2. Let me write number 2 right there. Okay. Number 3. We are finding F composed of G of X. F of X is X squared plus 7X minus 4. G of X is X minus 1. So what I'm going to do is because I'm doing F composed of G, that means I'm going to take G, which is X minus 1, and I am going to put it into both X's. Okay? So I've got to put it into each X that shows up in F of X. So I'm going to have X minus 1 squared plus 7 times X minus 1 minus 4. Some students were getting confused with this X minus 1 right here. So I'm going to do that off to the side. This is X minus 1 times X minus 1. And we have to FOIL that. So it's going to be X squared minus 1X minus 1X plus 1. So X times X is X squared. X times negative 1 is negative 1X. Negative 1 times X is negative 1X. Negative and negative is positive. So I have X squared minus 2X plus 1. And that goes right here because that's what this is right here. Now I'm going to distribute my 7. So I'm going to have 7X minus 7. Now I combine like terms. I don't have anything to combine the X with, so I keep it as X squared. Then I have negative 2X and positive 7X. That is going to give me positive 5X. Okay. Then I have positive 1, negative 7, and negative 4. And that gives me plus 10. So that is F composed of G of X. And so this right here is my final answer. Right there. Okay, and you can stop me if you need to at any point. Okay, number 4. F minus G of X. F of X is 8X minus 2. G of X is 4x minus 6. So I'm taking f of x, and then I'm going to subtract g of x. So I have 8x minus 2. The place that students make mistakes right here is they forget to distribute that negative. We are subtracting the entire g of x, so I have got to distribute the negative. So I have 8x minus 2 minus 4x plus 6. I combine like terms. 8x and negative 4x is 4x. Negative 2 and positive 6 is going to be positive 4. Okay? Okay, number 5. Okay, number 5. Now this one is one that you want to be able to think about without Desmos. You want to be able to think about what this means. So number 5 is we are graphing f of x equals x minus 3 squared minus 5. And here is my x and y axis. Because we have this squared right here, that means our parent function, and I'm going to do that in a different color. So our parent function is x squared, okay? That's our parent function. And x squared looks like this right here. That's what f squared looks like. Now, when we are graphing this, this right here means we go to the right, okay? So if it's inside the parentheses, whether it's absolute value, whether it's square root, whatever it is, if it's with the x, like this one is, it's going to be opposite in value. So that means we are sliding over to the right. So we're not doing minus, we're doing the opposite, okay? This is our x and y value, and that is true to value, so that we're going to go down. 2, 3, 4, 5. So my vertex is positive 3, negative 5, and then we follow the, then we follow the shape of our parent function. And we did have kind of a list of parent functions. X squared is a popular one. This function right here is cubed. That's the parent function, x cubed. This is the square root of x. I think cubed in the parabola. This is the absolute value of x. That's what that one looks like. We do have the identity line, which is the straight line. So you can look over those parent functions. I definitely will only use the super main one. Okay, now number 6 is one of the more challenging problems. So we definitely want to spend some time on number 6. Okay, the first thing that we are being asked to do is we are being asked to find the inverse of this function. Students get confused because of the algebra of this, okay? The algebra gets a little bit complex. The steps are pretty clear, or pretty straightforward. The first thing that I do is I replace f of x with y. That's what I do first. So I take out the f of x and I put in the y. So I have y equals x minus 10 over x plus 9. That's the first thing I do. The second thing that I do is I switch x and y. So everywhere there's an x, I put a y. And everywhere there's a y, I put an x. So now I have x equals y minus 10 over y plus 9. Okay? My third step is to solve for y. Okay? And solving for y is where students get confused. So the first thing I want you to think about is I want you to think about if I had the problem x over 4 equals 2. How would I solve for x in 2 equals x over 4? Well, I'd multiply both sides by 4. okay? And when I multiply the right-hand side by 4, what happens to those two 4s? They cancel, okay? And then I'm left with x equals 8. That is exactly what I'm going to do here. I am going to multiply both sides by my denominator, okay? So I'm multiplying both sides by y plus 9. On the right-hand side, my y plus 9 cancels out. I'm left with y minus 10, but I have to distribute my x. So I have x times y, and then I have 9x, okay? Now what I have to do is I have to get my y's together. Some students subtract this y from both sides, which is completely fine, and that's what I did. Some students will subtract xy from both sides, and it doesn't matter which direction you go in, you'll still get the correct answer. The negatives look different, and you would have just multiplied everything by -1 over -1. That's what happens, but they're both exactly the same. So now I have xy minus y plus 9x equals -10. I'm going to go right up here. So I have xy minus y plus 9x equals -10. Now I am going to subtract 9x from both sides. So I have xy minus y equals -10 minus 9x. Okay, this is where students get confused at this point because I need to factor out a y. Y is my GCF right here, so I need to factor that out. I have y times x minus 1. Okay, equals -10 minus 9x. I have gotten my y isolated, so now I divide by the x minus 1 on both sides. So I end up with y equals -10 minus 9x over x minus 1. Then my last step here is replace y with f inverse of x. And so my final answer is f inverse of x equals -10 minus 9x over x minus 1. Okay? Now, I'm going to rewrite this on the next screen so that we can talk about a couple more things. Okay, so my original function was f of x equals x minus 10 over x plus 9. Okay, my inverse function is f inverse of x equals -10 minus 9x over x minus 1. Now, some students went the other direction. So instead of subtracting y on both sides on this step, they subtracted xy on both sides. And you'd get to the same spot, but the final answer would look like f inverse of x, and the numerator would be positive, okay, 10 plus 9x, and then it would be 1 minus x in the denominator. These are equivalent. These are completely equivalent. Okay, so now I need to find the domain and range of each of these. So I'm going to find the domain of my original function. So I am looking first at the domain of my original function. So I am looking at this denominator right here, the x plus 9. So the only thing that I'm looking at is at the denominator, okay? My numerator can be anything. It can be 0, it can be positive, it can be negative. I can't have 0 in my denominator here. So I have x plus 9 cannot be 0. So when I solve this for x, I get that my x value cannot be negative 9. That is my domain. So then I have negative infinity to negative 9 and negative 9 to infinity. The domain of my original function is the range of my inverse. Okay? The domain of my original function is the range of my inverse. Now I'm going to look at this denominator right here, x minus 1. So I am looking at the domain for my inverse. Okay, so I have x minus 1 cannot be 0. So what is it that x cannot be? It can't be positive 1. Okay, so my domain for my inverse is negative infinity to positive 1. Positive 1 to infinity. The domain of my inverse is the range for my original. Okay? Questions on that one?
Just need one second.
Sure. We good? Okay. So now the directions for number 7 say find the x and y intercepts for the function f of x equals 3x cubed minus x squared minus 12x plus 4. Okay? So to find the y-intercept, I am going to plug 0 in for x. So to find the y-intercept, I'm going to plug the 0 in for x. So I have 3 times 0 cubed minus 0 squared minus 12 times 0 plus 4. So all of these cancel out and give me 0. And so my y-intercept is going to be 4. Now you can leave that as y equals 4, or you can write 0, 4. It does not matter to me. It's completely fine. My x-intercepts, what I do is I set this function equal to 0. So I have 0 equals 3x to the third minus x squared minus 12x plus 4. And I'm going to factor. Okay? And I can factor this by grouping. So the first 2, I can take out an x squared. And I'm left with 3x minus 1. The next 2, I can take out a negative 4. A negative 4. Do you see how I've got a negative sign right there? That gives me the indication that I need to pull out a negative. So I'm going to pull out a negative 4. And then I'm going to be left with 3x minus 1. So when I factor this, I have x squared minus 4 equals 3x minus 1. X squared minus 4 can be factored again. I get x plus 2 times x minus 2, because that's the difference of perfect squares. And then I have 3x minus 1. To get my x-intercepts, I'm going to set each one of these equal to 0. And 3x minus 1 equals 0. So x plus 2 is x equals negative 2. X minus 2 is going to be x equals 2. 3x minus 1 is going to be x equals 1/3. I add 1 to both sides and I get 3x equals 1. I divide both sides by 3 and I get 1/3. So my x-intercepts are -2, 0, 2, 0, and 1/3, 0. Now, you can leave it in -2, 2, and 1/3. That's fine. You can leave it like that. Okay? Number 8 says, find the equation for the desired transformation. So I am reflecting the square root of x across the x-axis. Okay? Then I shift right 1 unit. Okay? Now, when I reflect across the x-axis, okay, am I going to put the negative with the x, or am I going to put the negative outside the x?
With.
It's actually the opposite. It's outside. Okay? So I'm going to put my negative on the outside of this. Okay? If I put it with it, it would reflect across the y-axis. Okay? Now, if I want to shift it 1 unit to the right, I'm moving it right to left. So do I put it inside with the x, or do I put it outside? Inside. And what do I put, plus or minus? Good. Okay, so there it is. F of x. Okay, now if you wanted to draw it, you could. You certainly don't have to, because you won't be using Desmos. There is the square root of x. I reflect it across the x, and then I move it 1 unit to the right. So it's going to look something like that. That's what it's going to look like. Okay? I have to be out of this. Okay, for problem number 9, we are looking for parallel and perpendicular lines. We're looking for parallel and perpendicular lines. My original line is 4x. Let me write original here. So my original line is 4x minus 5y equals 12. And what I need to do is I need to put this in y equals mx plus b form so that I can identify the slope. So I'm going to solve for y. So I'm subtracting 4x from both sides. So I have negative 5y equals negative 4x plus 12. My next step is to divide everything by negative 5. So for my original line, I get y equals 4 over 5x minus 12 over 5. Now, the only thing that I need from my original line is the slope. So the slope of my original line is 4/5, and that's what I need. So I am going to take the slope of my original line, and I am going to use it to determine my parallel line. Now, my original problem says that the point goes through -1, 1. Let me just check that to make sure I've got the right point. Yes. Okay, so the new lines go through the point -1, 1. Okay, so my parallel line is going to have a slope of 4/5, and it is going to go through the point -1, 1. So I'm going to use point slope form of my line. So that's y minus y sub 1 equals slope times x minus x sub 1. So I'm going to put in y minus 1 equals 4/5 for my slope, and x minus -1, and that minus a negative becomes a plus. So my next step is to distribute my 4/5. So I have y minus 1 equals 4/5 x plus 4/5. I'm distributing this 4/5 to both, so don't forget to distribute that there. Now I'm going to add +1 to both sides. When I add +1 to the right-hand side, I've got to change that +1 to something in terms of 5. So 5/5 is the same thing as +1. 5/5 is 1. So I can now add 4/5 and 5/5. So I have y equals 4/5 x plus 9/5. And I did this so that I could get a common denominator right there. So my final answer for the parallel line is y equals 4/5 x plus 9. That is the equation for the line that is parallel to my original line. Now I want to do my line that is perpendicular to my original line. The slope that I'm going to use is going to be opposite in sign. So instead of having a positive slope, I'm going to have a negative slope. And I'm going to flip my 4/5. So it's going to be 5/4. So it's opposite in sign. So instead of positive, it's negative. And then instead of 4/5, it's 5/4. So it's the negative reciprocal. Negative 5/4. I'm going to plug that into my point slope form. So I have y minus 1 equals negative 5/4 and x plus 1. So I'm going to distribute my negative 5/4 to both. And again, I'm going to add 1 to both sides. But again, we've got to keep it as, we've got to add fractions. So I've got negative 5/4. That positive 1 is going to become 4/4 because that gives me a common denominator. So +1 and +4/4 are the same thing. Negative 5/4 plus 4/4 is negative 1/4. So that is my line that's perpendicular. Y equals negative 5/4 x minus 1/4. Okay, now I have one more problem that I'm going to show you how to do, and this is the increasing and decreasing lines. So let me sketch this graph again, just so we can all see what it looks like. Okay, here is the graph for number 10. We are identifying the increasing, decreasing, and constant intervals. And then I also want you to look at the domain and the range. So the first one that we're going to do is increasing. So here are two areas on our graph that are increasing. And when we are talking about intervals, I am talking about the x values for those intervals. So where my pink, where I have that highlighted, my x my x coordinates that are associated with that are this whole highlighted area right here. So that is going to be negative infinity to this x value right here, which is -3. Okay, so that is increasing. Then my next one starts at 0 and goes to +3. So my other increasing is 0 to 3. For decreasing, we're going to look at that with green. So my decreasing, I've got it right here. Here I'm decreasing, and here I'm decreasing. Okay, but I'm looking at the x values. So my x values start right here at -3 and I go to 0. Okay, so I'm looking at the x values of those 2 points. So I have -3 to 0, and then I have, again, I start right here at 3 and I go to infinity. So those are my decreasing intervals. I do not have any constants. So that's like a horizontal line. So I don't have any intervals where my graph is constant. Now my domain focuses on my x values, and if you can, and when you look at my domain, you will see that my domain is all real numbers because I'm going on forever in the directions of my graph, and so it's all real numbers. However, my range, I don't ever go above this dotted line right here, and that dotted line right there is x equals 6. So my range, I've got negative infinity to 6. And on the answer sheet, I've got a parentheses right there, but it should be a bracket. So it should be because 6 is included. So for my range, I go from negative infinity to 6. Okay, so hopefully these helped. Please let me know if you've got any questions on this classwork.